So, the periodic table can be keyed for many things. Today, we're going to key it according to metals, nonmetals, and metalloids. We're going to start by taking a look at one of the most famous and important features on the periodic table, which is the staircase. The staircase is located here, and it separates the metals, which are below and to the left, with the exception of hydrogen, and from the nonmetals, which are over here, above and to the right. And we'll also talk about the metalloids, which border or sit right along the staircase. So right now, let's start with the metals. Metals make up most of the table, as you can see. We said this is the portion of the periodic table that is metals is actually everything in here. So it's most of the periodic table. All of the metals, with the exception of mercury down here, are solids. Mercury at STP, which is standard temperature and pressure, or a lot of times you'll just hear me say, just to keep it simple, at room temperature, mercury is a liquid. All the rest of the metals are solids. Now, metals have four basic properties. In order for an element to be classified as a metal, it has to have all four of the properties you see here. It must be malleable, ductile, have luster, and be a good conductor of both heat and electricity. Now, the elements that you guys think of as metals most often are found in this portion of the table, which we learned earlier, is called the transition metals. Elements like copper, iron, zinc. In light bulbs, you'll find tungsten filaments in the old light bulbs. Silver, gold. Most of the metals you're familiar with, whether it's from construction, iron fences, cars, pots and pans, silverware, those metals are transition metals, and they're the least active metals. The four characteristics, the four properties we talked about that all metals have to have, the first, malleable, means that when you hit a metal with a hammer, it doesn't shatter, and you'll actually get a chance to hit metals with a hammer, and you'll learn that you can hammer them into sheets, you can bend them, you can mold them. That means that they are malleable. If you hit it and it shatters, then it's not malleable. Ductile means that the metal can be drawn into wire. We're not going to actually test ductility in the lab. We assume basically that if something is malleable, it's ductile. In order for us to draw something or stretch it into wire, we'd have to heat it to a pretty high temperature and then pull it and stretch it. It's a more involved lab that we really don't have the facilities to do here. The third property is luster. Luster means that it's shiny. What's important is it's shiny when it's polished. You're going to look at a couple of the samples in the lab that we're going to do to basically classify elements as metals, nonmetals, or metalloids, and you'll see that some appear to be shiny, but when they get polished, they actually become dull, scratched. If that's the case, that means it doesn't have metallic luster. Things with luster, when you polish them, again, with something that's an abrasive, a scouring pad, steel wool, when you polish a metal or something that has luster, it becomes more shiny, not scratched and dull. And the last one is conductivity. All metals are good conductors. They conduct electricity and heat. And I just wanted to spend a quick minute talking about why that is, because this is going to come up all year long, and it's almost definitely going to appear on the Regents exam. The reason that metals are good conductors is because they have, this is the phrase you'll see over and over, a sea of mobile valence electrons. Those are the electrons, we learned this before, that are found in the outermost shell. And what this means, another way of saying it, is these electrons are what we call delocalized electrons. They're not really owned by any of the metal atoms, and they can flow freely. That's where the term C comes in, because just like water, if you were to take water in a big container and start to slosh it back and forth and tip the container back and forth, you'd get waves of water that slosh back and forth, and you could feel them slamming into the walls of the container. When the water gets moving in those waves, it has energy. Energy can do, if something has energy, it can do work. And when you have metals uh, with the sea of mobile valence electrons, and you use them for, say, a power cord, you hook them up to a power source, those mobile valence electrons can act like water swaying back and forth, generating wave energy, and that energy can be used to do work, like charge your iPod, your iPhone, power your TV, all the electrical devices that you could never imagine living without. Metals also like to lose electrons, and they form positive ions. Now, the nonmetals are found to the right or above the staircase. These guys up here. And the nonmetals sort of like we could say they have the opposite properties of the metals. We'll combine 1 and 2 here. Property 3, property 4, we sort of put malleable and ductile together. These guys aren't malleable. They're mostly gases and solids. Their exception is bromine, and that's a liquid. Like I started to say, they're not malleable, which means another way of saying that is brittle. Means they shatter when you hit them with a hammer. They lack luster. They're dull, which means when you go to polish them or scrub them, they actually don't get more shiny. They get less shiny, and they're non or poor conductors. Now, these guys can have either 1 or 0 properties of a metal, and a good example of this you'll find in the lab. Carbon is a good conductor. That's the only property of a metal that carbon has, but it does have it. So they may have 1 or 0, but no more than 1. And the last one we have, the third, the metalloids are located on the staircase. And these guys, you could probably guess, also called the semi-metals. These guys have 2 properties of a metal. All right, like I said, they're found along the staircase. These 2 properties are usually that they are good conductors and they have luster. The reason you don't see them with 3 is because if they had 3 properties, that would be either malleable or ductile, and if they have one of those, they have the other. So again, you find your semi-metals along the staircase. The exceptions in this case are aluminum and astatine. Aluminum because it's a metal, and astatine because it's radioactive. Last step, make sure all of you complete the practice. Remember, this is an important part. Make the connections with all the information you just learned, and we'll see you tomorrow.